All right, I think we're live now. Yes, exactly. Hello, how is everyone doing? Woo, choo choo, parametric camp, another Friday. Woo woo. All right, I'm perhaps a little more pumped up than usual today because we have a very cool stream prepared for today, thanks to the help of my friend Arasto, who is right now on the backstage. I will show you a little bit of how that works in a little bit. But yes, so let's do the formal introduction. Good morning, good afternoon, good evening, everyone. My name is Jose Luis, in case it's your first time here. That guy over there, this is Parametric Cam. We do live streams on computational design, which we then chop into edited videos that we publish into series. I'm very happy to see familiar faces. Kartik, Andres, Said, good to see you. I see Petingo and Joe. I don't know if I've seen you before around, but you're more than welcome to be here. And the quick spoiler, if you're new to the channel and you want to learn more about what we do, feel free to join us in one of the social handles, etc., etc. And if you want to learn more, if you have questions about coding, if you want to learn, if you want to join the community and the conversations that we have throughout the weeks in between live streams, you're more than welcome to join our Discord server. There's a link to that server in this description, as well as a link to a Google Calendar that you can also subscribe to know when we go live, which we typically announce over social media as well. But you know, anyway, so what are we doing today? So if you follow us, you may know that we are in the middle of recording a playlist that is called Advanced Development in Grasshopper. And we're actually wrapping a large chunk of videos that focused on C# scripting. And we're going to move on very soon, as of next week, really. We're going to move writing our own native Grasshopper plugins and compiling them and all that goodness, but that's going to happen next week. So what I want to do is I want to actually finish this large section of C# scripting with a bang, if you will, with something very cool. And that's why I have invited a friend of mine from the Parametric Cam community who has done a really cool contribution to the world, and he's going to help me put together this live stream. All right, so I'm actually going to introduce him right now. Oh, wait, this is a sample file that we were working on before. Arasto, are you there? You are there.
Hi.
You are there. Can you say hi, and can we verify that the audience can hear your audio?
Okay, hi. So can anyone hear me? Hello.
All right, people in the chat, can we verify that you can hear him? All right, there's probably a mic is causing issues. I know, I'm having issues with the microphone. It's kind of a problem. Yes, people can hear you. All right.
Oh,
All right, cool. So,
you. I guess.
all right, so you're officially on the channel now. So, what are we doing today? So, for those of you who may not know Arasto, would you like to introduce yourself a little bit?
Yeah, of course. Yeah. So, well, first of all, hi everyone. So my name is Arastu, and I am from Iran. At the moment, I'm a second-year master's degree student at Keio University in Japan. And I'm basically like working on my master's thesis. And the thing that we're going to be showing today is more like the plugin that I've been working on, which is called Remo Sharp. And with Remo Sharp, we basically can do collaborative work in real time remotely. So by remotely, I mean like you can do it with internet and local areas and anything. And I guess that's all.
That is very cool. Arasto's been a long time collaborator here at Parametric Camp, but part of the community. He's one of the administrators in Discord, and he has been doing a lot of work these past 2 years in this really cool. Is it open source? Have you open sourced it yet?
Yeah, it is open source.
It's in this open source tool called Remo Sharp, which we're going to try today because it's actually very freaking cool. So how are we going to do this? So, if you remember, let me actually pull up my script that I have somewhere here. Yes, so we just did we did custom preview. So then this video is scripting from text inputs. That's where we're going. Oh, wait. So I was just hiding you with my, oh yeah, because I'm capturing my other screen. Okay, so I can't do that anymore. Okay, so what we're doing today is now we're going to design a video where we're going to explain how to do scripting in C Sharp, script components from text inputs. And we're going to use Remo Sharp for that. So I think the way we're going to do that is that I'm going to put you on hold, Arasto, if you don't mind, because I would like to start the video and do the whole like, hey, welcome, this is a new video, blah, 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 whatever, and then explain what we're going to do in the video and then introduce you and bring you in. And then as I bring you in, then we're going to do the examples that we have discussed when we were preparing this video a few minutes ago. Okay? How does that sound?
Yep.
Are you okay with me moving you to backstage already? By the way, I don't know if this was clear, but Arasto is in Japan right now, whereas I am in Boston. We were able to connect the stream with some, technology, this kind of crazy thing, But he is in Japan right now. We're 13 hours away from each other. So
Yes.
So how beautiful is the world, huh? That we're so interconnected. So Arasto, I'm going to move you to the backstage. I'm going to do the formal intro to the video, and then I will bring you in again, okay? And when I bring you in, I will probably also ask you to introduce yourself briefly, as you just did, for the recording, and then I will move on to working on the examples. You're saying?
Yeah, just one quick fact.
Yeah.
Today's my birthday too.
Are you kidding me?
Yeah, it is.
Can we please say happy birthday to Arasto? Happy birthday to you. I'm not going to do the whole thing. But this is awesome.
Yeah.
How did it take you 2 hours to tell me?
Oh, I forgot, I guess. I was too excited about all the things. So yeah, technically it was, but in America it still is.
Okay. So, well, yeah. In most of the world, because Japan is very far ahead of the time zones, in most of the world, it's still your birthday.
Still is.
So happy birthday. I see people in the chat already wishing you happy birthday. So
thank you. Thank you very much.
That's very cool. All right. Well, what a crazy birthday or birthday gift to
it is.
Share some of your work with the world, huh? Oh, I see a lot of happy birthdays actually in the chat. We have quite some lag, I can notice. We have at least a minute lag.
Yeah, unfortunately, yes.
Yeah.
And thank you, everyone. Thanks.
All right, cool. Okay, so let's get started then. We have this is stuff from before. And okay, so I'm going to start the channel where I'm going to reset the file. I'm going to come here. I still got you on the screen. So what are we going to do? How am I going to start this? Okay, so I'm just going to do a simple introduction. Remember, Arasto, that even if you're not on the screen, your audio is still piped. Okay, so I see you muted yourself, but yeah. All right, so I'm going to do this. Okay, let's do intro to the video. Hello, this is Jose Luis here, and welcome to another video in this series, not intro anymore, advanced introduction. What is the name of the series? I have totally forgot. Advanced development in Grasshopper. Okay, we're redoing this again. Redoing this. Hi, this is Jose Luis here, and welcome to another video in this series, Advanced Development in Grasshopper. We have done a lot of development in C# scripting components, and we're going to kind of wrap this up, but I would actually like to wrap it up with a fun and special video that we have prepared for you, where we're going to learn a special technique on how can we write code inside C# components, but instead of doing it inside the editor that comes out of the box with Grasshopper, we can do it in a more perhaps external sources of input. This is going to be different from the video we did previously, where we were using script parasite script, I forget the name. It's going to be different in the ways that you're going to see. But for this video, I have a tiny surprise for you, which is that I would actually like to invite the author of the plugin that we're going to be using, called Remo Sharp. And I would like to invite the author, who is our friend from the Parametric Camp community, Arasto. Arasto, you're on the video right now. Hi, how are you doing?
Hi everyone.
Hi, would you like to introduce yourself?
Hi everyone. So my name is Arastu, and I'm from Iran. At the moment, I am a master's degree student at Keio University in Japan, and basically what I'm doing is, well, like developing Remo Sharp, which is like a tool for collaborative work remotely in real time. So I guess that's all. Yes.
That is very awesome. And Remo Sharp is the tool that we're going to be using today in this video, just for the sake of showing you all the perhaps like more advanced and more cool things that you can do inside of the Grasshopper framework. I would like to say a few things. The Remo Sharp is open source, which is always a great thing because it's not only available and free to use for everyone, but it's also something that we can use to learn how to improve our coding skills. So big thumbs up for you, Aras too, for doing that. Another thing, this work that you're seeing in this video right now is part of Arastu's master's thesis at Keio University in Japan. So expect that whatever you see today is probably going to be much more advanced and much more developed if you're watching this video in sometime in the near future, because he's very actively working on this right now. And last but not least, what do I want to say? Oh yeah, Arastu is right now in Japan as we are recording this very video that you're seeing right now, whereas I am in Boston. So we are 13 hours apart, which is very cool for the reasons that you will see very soon, because of how we're going to be showing the possibilities of using Remo Sharp as a collaborative remote tool between different people in different parts of the world. All right? Beautiful.
Yeah.
So with that, what we're going to do is we're going to start with a few examples of the basics of how Remo Sharp works, why it's interesting, and then we will move on to a few more advanced examples. So let me prepare a few things on my end. All right, cool. So, all right. So what are we doing next? You're still in the video. I think I'm going to keep you there for the foreseeable future. So the first thing we're going to do is, wow, we need to explain that people need to download and install. Ooh. Well, okay, for the basic features, so if you're not sharing canvases and Bengesh, correct? Well, Bengesh
Yes.
is mostly for, all right. And then for the
Well,
advanced
we
features,
need Bangish for everything.
you need what, sorry?
We need Bangish for almost everything. So anything that requires like sending data.
Okay. All right, and so that's one thing. And then for the advanced features, we need to do through the installation process with Python, etc., etc. We're not going to cover that on the video. I'm going to point to your YouTube, to your playlist. I'm going to point to your playlist for instructions on how to do that. Okay? All right, so we're going to start the video. Let me then open Firefox and get Food for Rhino here and bang Remo Sharp. And then I'm going to open another instance of this and Bengesh. I never know how to type it. Oh, I actually did type it correctly. Okay. All right. right, so we're going to explain that we need to install both from Food for Rhino.
Yes.
Victor is suggesting that you use the packet manager. RS2, okay. Then we do that. And then the first example that we're going to do is super simple, which is going to be just placing a Remo Sharp component, a toggle, a Boolean toggle. We're going to take it on, it's going to turn on, and then we're going to, we have this component. Let's say I put two components here, and I plug in a panel. Well, I'm going to need to raise this because you're on the, okay. And then I'm going to plug in another panel here. The script is going to be this one, and then it gets disconnected. And then I do A plus B. And then I change this to double. I change this to double. Huh. Why is this not working? Oh, yeah. Stupid. Okay. A equals this. Oh, because I'm missing a semicolon. Seriously? Oh my God. I should not, we should delete this from, am I still? Why is this giving an error? Oh, okay. All right. I really need more coffee today. Okay. And this is working. All right. So we're going to do that. And then we're going to show that this works. And then I'm going to change multiply, and we're going to change this. Okay, so that's going to be the first video we're going to do. All right, Arasto, we're going into recording mode. Okay, I had my finger here. Okay, all right. Oh, wait. I want to bring in your playlist here. So, first things first, let's start by how do we install Remo Sharp in the first place? Well, the first thing that we need to do is we need to go to Food for Rhino. And if you don't have an account, then you get an account like you do for basically any plugin. And then what we're going to do is you're going to look for Remo Sharp. You're going to see that you have the plugin here by Arastu, who is that guy over there. And you just download the latest version, and then you go to your Grasshopper files, special folders, components, and then here you can you can create a folder called Remo Sharp, for example, and you just dump the files here, and then you restart your Rhino. One thing that is important to note is that Remo Sharp is extremely designed to do real-time collaboration between different parties in different places in the world. So it uses a lot of network communication, global network communication, and specifically it uses a lot of WebSocket technology. So you might be familiar with WebSocket from other videos in this channel. So in order to use WebSocket, actually, Remo Sharp depends on this other library by Beruz, also a friend from the community. This other plugin called Bengesh, which is the one that carries all the heavy load of doing the WebSocket communication. So it's very, very advisable that you also download and install Bengesh as part of, as a team, as a partner with Remo Sharp, okay? This might change in the future. If you're looking at this video in the future, maybe just look through the documentation if this is still necessary. But Bengesh is still a really cool plugin to have in any case, all right? So I suggest you install both. That's all you need for the basic features. For the more advanced features, as we will see later in this video, there is some installation and some special configuration that needs to be done with Python, again, as of the recording of this video. So the best place to know how to understand and how to install that is the main documentation, the playlist of tutorials that Arasto has put together. We will talk about this later on, but you see there's a video specifically on how to download and install everything. So we will go over that later on. And once you have Remo Sharp and Bangesh, you have a tab on your computer. I'm going to suggest, this is just a recommendation, Arasto. There's this thing that you can do where you can assign an icon to the tiny tab of the plugins, so that instead of like a big R, that what you get is a tiny icon. So this is a I don't know, feature request for the future. So you have here the Remo Sharp. Remo Sharp is actually getting quite complex again because of all the possibilities that it gives us for remote collaboration. But today we're going to start with the basics. The basics is that in the Remo Sharp tab, there is the main Remo Sharp component, which is a tool that converts text that's coming from anywhere into a C# component. I'm going to drop this here on my canvas. And the way this works is that as soon as you plug in a Boolean toggle to the update input saying, I want to update this, then this magic C# component, if you will, shows up on the screen that is under the hood with some technology and code magic, is actually connected to the main Remo Sharp controller, if you will. All right. What this does is that it gives us a C# script that we can customize. So for example, let's say right away, I'm going to say, this is going to be a double, Y is going to be a double, and I'm going to add another input, a Z input that I'm also going to turn into a double, right? And if I wanted, I could really double click and I could start writing something here to create a point from this or to add components together. But that's not the point of this video, because the point of this video is how to do that programmatically from external sources. The way Remo Sharp, let me plug in a few sliders here just for the sake of a few sliders here. All right. So we have a few sliders here. And then what I would like to do now is to somehow programmatically inject code in this C# script component. I'm really clumsy with my tongue today. In this C# script component that is code that is coming from some external source. The simplest external source that I can think of right now is just a panel. I'm going to write a panel here, and I'm going to write as if I were inside of the component here. I'm going to imagine that I want to add the result, the output. I want A to be equal to A plus Y plus C. If I did that, you can see how the component immediately takes that value right away, okay? But I don't want to script inside of the component, so I'm going to remove the code. What I want is to inject that code externally. So I'm going to plug in that code here in a panel, and then I'm going to plug in the panel into the input that is called the script part. Remo Sharp has different inputs for the different parts of the C# script component where you can inject that code. And you can see that as I plug this in, all of a sudden, my component is now working and is giving me an output that is the addition of these three numbers. So you can see 44, whatever. All right. This is happening because the Remo Sharp controller is updating in real time the code that is inside of this script with this panel that I have here, with the code that is coming from the panel. So if, for example, I change this to a multiplication, you can see that this updates right away. And now the result is 84 point something something. And if I update this with a multiplication, then I also get like a 344 or whatever. All right. How cool is that? All right. So one thing, if you don't really like the development environment inside C# script components or whatever, you can use panels to write code, simple code. All right. That's the first application. But external sources don't need to be constrained or bound to this simple panel input. Let us show you another technique that can be really cool to bring in code. And instead of doing it from the panel, perhaps we can do it from an external file that is living inside of our system. Let's take a look at how we could do that. All right. So now let's try that first and then do the video. All right. Okay, so I'm going to create a folder here. The folder is going to be called, I don't know, Remo Sharp. Can I do? Oh, yeah, I can have a, that's probably not very safe. Remo Sharp. All right, so I'm going to create here a file. I'm going to call this external text. Okay, I'm going to open drop this file here, external text, and I'm going to say A is going to be equal to the X times Y divided by Z, for example. All right, I'm going to save that. And I asked too, Andres is asking in the chat, what do we do with the Remo Sharp servers files? Would you like to answer that?
Yeah, of course. Well, the Remo Sharp server files are more like tools for communication between multiple computers. And so Remo Sharp actually is made out of two different parts, basically. So one part is for programmers who can write C# code and can like script remotely. The other part is for non-programmers. And most of the server files that you can see over there are more like gears towards that. And basically what happens is, simply speaking, we're going to be like broadcasting the whole canvas image of a main computer for like multiple users, and those multiple users are going to be working on parts of that canvas at the same time in real time. So those files actually like basically work on those things. So if you want to see how those work, I would highly suggest you take a look at the playlist that I recorded. It contains everything about how we can use all of those.
All right, this is working. Ooh, I like when things work. All right. So I'm going to undo stuff here.
Oh, we actually have one of my friends from school. Hey, Koki-san. Hi.
Koki-san.
Yeah. Yeah, actually, Koki-san is one of my friends from Keio, and he's going to be graduating, and he's going to become a master's student, I guess, next semester. So, cool.
Nice, congratulations, Koki.
Congratulations, of course.
Anticipated congratulations. Beautiful. Okay, I think I got this. So we are ready to continue. You ready, Rastu?
Yeah, sure.
Okay, let's do this. Right, so external files. Did I say this in the starting over? Did I say when I did the previous clip, did I say that we were going to do external files? Do you remember, Arastu?
We were talking about using a local file on your computer.
Okay, all right. Okay, so we can start. I don't need to introduce the topic again. Okay. Your clicking is hearable. Arastu?
Oh, really?
Yes. Okay. All right, so let's set the thing up. What we want to do is we want to pipe in to our Remo Sharp controller the source or the contents of an external file. So what I'm going to do is I'm going to dock Rhino right behind Grasshopper. I'm going to create a folder on my system. I'm going to call it Remo Sharp, for example. And then I am going to open an instance of Visual Studio Code. In this instance, I'm going to drop my Remo Sharp folder so that I have like all the files that are in this folder available in Visual Studio Code. And then I'm going to right click on Remo Sharp and I'm going to create a new file. This file, I'm going to call it, for example, sourcecode.txt, because it can be any type of file that can contain text. And as I do that, you can see that I get my file here, all right? And I'm going to start with something very simple. I'm going to say the output of this component needs to be hello Remo Sharp, for example. Sharp. All right, as simple as that. I'm going to save this, okay? And we have a file that contains code ready to go. So what I'm going to do is I'm going to go to Grasshopper and I'm going to try to pipe the contents of this file that I have in my system into the script input here. So how am I going to do this? I'm going to disconnect this right now. This goes empty, so now it's not working. And then I'm going to add a read file component. This component a file on your system in real time, and it actually updates if there's any change in that file. So I'm going to plug it here so that we can see the contents of that file. And then what this component needs is the path of the file that we're going to read. So the path in my case is this is my desktop. So I'm going to plug that here on the panel. So where is my panel here? So I'm going to double click here and say, this is Remo Sharp, and then I'm going to add that the file name is called sourcecode.txt. All right. As I plug that into my reader, you can see that my reader is already giving me the content of that file. And guess what? If I plug that into Remo Sharp, boom, then the content of the script is already reading from the external file that we're piping in. So if I go here to the output, you can see over Arasto's head, you can see the hello Remo Sharp message, all right? What's beautiful about this is that as now I can use my external editor as a real-time editor for this Grasshopper definition. Because if I say now, okay, the output should be A plus Y plus C and a semicolon, as soon as I save this, Grasshopper picks up that change. It shows me here in the panel, but it also updates that in the C# script component, all right? Which is pretty cool. So I can also just do like this multiplication, and this is a sum, whatever. It gets picked up, it gets updated. The result is updated. I can even be a little smarter and say, well, if I know I am writing C# code, instead of saving the file as txt, what I can do is I can save it with the extension CS, which stands for C#. And by doing that, what happens is that the Visual Studio Code all of a sudden recognizes that this code is C# code, and then it gives me highlights, but it also gives me smart suggestions, okay? Which means that I can have a sort of smarter editor outside in order to change my scripts here, okay? Which is pretty cool. Anyway, if you're going to really use if what you're looking for is actually using an external editor for serious coding inside of a C# script component, perhaps the Script Parasite tool, it's a little better because it already incorporates the libraries and it gives you suggestions that are based on Rhino common suggestions, etc. This is not exactly the focus of Remo Sharp. Remo Sharp is more about collaboration, etc. Because what we're going to do in the next example is I would like to reinforce this idea that the text as a string of text can come from anywhere. It can come from a panel, it can come from a file that we have on our system that we are reading live, we're watching this file live, but it could come from any other place. Literally, it could come from anywhere in the world. So what I would actually like to do is to show an example of how now what we can do is we can connect the Remo Sharp controller to a network, a communication network using, for example, WebSocket clients and servers, and have people from somewhere in the world, let's say, for example, Tokyo, right? And be the ones who actually write code on their end and send it to my machine and gets piped in to my to my file definition here. All right. Give us a second to prepare that sample for you. All right. I see some
Okay.
robots.
Robots.
Yeah. Is this a Russian spam robot? Okay. All right. So we have that. Arastu, we're gonna do. Can we run a dry check?
Yeah, I already have a script for a list of points that are like a vertical list of points. So I'm gonna send it through, let's say, WebSocket server one.
All right. Let me try. Let me save this file before I Remo Sharp local, for example. And so I'm going
And,
to
would
save
you like to
that.
show?
Um,
Would you like to show how we can extract text from C# components too, with the eavesdrop? It's not that hard.
say that again.
With the eavesdrop component, we can actually like extract code from C# component within Grasshopper. So would you like to show that too?
Oh, with the eavesdrop.
Yeah.
Oh, okay.
So basically, yeah, we create one C# component and then we put eavesdrop right in front of it. And we have to connect those two together.
And the input, what is the input?
The input has to be one of the inputs of the C# component. The only thing that matters is whenever I'm updating the C# component, the eavesdrop component updates right afterwards. So there's no, it's not really, it doesn't matter uh, what output we're using. What it matters is that these two components stay connected. That's it.
Okay. I think I can see an example right now of how we could use
Mm.
this in an example. So I think we're going to pass on this one.
Yeah. Okay.
All right.
It's already included in the playlist. So yeah, sure.
Okay. Yeah. All right. So I'm going to. Interesting.
Also, it's a little bit dangerous, I guess. It can get a little bit buggy, so maybe we should not include it.
You know your life right now, right?
Yeah, I mean by buggy, I mean like where you put this component and
Mhm.
how it calculates the closest C# component, that might become an issue. Like if let's just say we shouldn't put it in front of the C# component that Remo Sharp is creating. Just
All right, so I'm going to use the client template. I'm going to WebSocket server samples. I'm going to add. Which one are we using?
number one.
Number one? Okay. So actually for those this, I believe that if you connect to the same server, you may also get the changes that Arasto is going to be doing from his on his end. No? Is that correct?
Yeah, they can.
So you will see those changes on my end, but you also could see those in your end. All right, so I'm connected to server number one. Can you send something?
Okay, here we go. Did you get it?
Yes, I did. All right.
Okay.
Okay, can
So
you?
I just changed it.
Yes, we know, Arc. I have microphone issues. It just stops working every here and then. Um, all right, a couple things. The first thing that I would like you to send me is something closer to what we're doing in the previous two examples. So I would like you to send me a list, like a simple line that is capital A equals X plus Y plus Z, which is the component that we have on our end. All right.
Okay.
Once we show that working, then you can show this more elaborate example. All right.
Okay, so give me 1 second to create that.
Victor, what is RMA?
Okay, so you want me to create A equals to X plus Y plus Z.
Z, exactly.
Right.
There you go. All right, and then we can pipe that in, and then it works. Yeah, great. Okay, so refund merchandise authorization. I see. Okay. All right, so how are we going to do this? We're going to do this by creating a WebSocket server. What is Bengesh? We're going to create a WebSocket server. We're going to take the server from one of the servers on your list, and then we are going to plug it in. And then as soon as I got it plugged in, let's use server 2, okay? So that it starts from scratch. As soon as I plug it in and I get a hello world or whatever, then I'm going to ask you to send something. And I'm going to ask you to send that A equals blah, 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 whatever, so that people on the video can see like, oh, it just changed, you know?
Okay.
Actually, you know what? Before, to make it a bit more fun, would you mind when I tell you like, hey, I'm connected to server number 2, do you mind sending like a quick message, like a string message, something like hello Jose Luis or hello parametric camp or whatever, so that we can, or hi, I'm Arasto or something like that, so that we can see like, oh, this guy from Japan is sending messages here. And then we can say, well, any message can go. So a message can be human text or it can be a string of code. All right. And then you change to A equals A plus Y plus Z. And then once that is working, you copy paste this other more elaborate code, like the sequence of points that you were doing.
Yeah, sure.
All right. Okay. All right. So let's do that. I'm going to go for it. You ready?
Sure.
Beautiful. In order to do this, what we're going to do is, first of all, using Bengesh, we're going to create a WebSocket client. So I'm going to go to Bengesh, I'm going to go to WebSocket, and I'm going to start a WebSocket client. I'm going to put here a toggle so that more like a button in this case. I'm going to put a Boolean button to be able to reset the WebSocket server, the WebSocket client whenever I want. And then the URL, what are we going to use for that one? Well, it turns out that Arasto has gone through the effort of putting together a bunch of servers that we can use publicly and for free. And in order to get the address of those servers, you can go to communication tools in Remo Sharp and go to WebSocket server samples. As you do that, you can drop here a component. The component will give you the address of a bunch of servers that Arasto is maintaining himself. This may or may not change in the future, so just make sure that whenever you watch this video, read through the documentation. And for example, because he has a lot of different servers, we have agreed that we're going to be using server number 2. All right. So what that means is that this component gives me the URL of a WebSocket component that is living in the cloud. So for example, Remo Sharp public server. And then we're going to plug this here into the URL. All right. Beautiful. I'm going to now connect a WebSocket reader. So I'm going to get a receiver. I'm going to connect it to the client so that I can see on my screen if there are any messages that are coming from the outside world. All right, so I'm going to actually maximize this. And I think at this point, Arasto, I am connected and I think things work on my end. Would you fancy sending some message from your end all the way from Japan?
Okay. All the way from Japan and messages coming in.
Oh, what? What just happened? This is magic. I love WebSockets.
Oh, yeah.
I love internet communication. Beautiful. All right. So, as we mentioned before, the whole point of this example is that because we can plug into the Remo Sharp controller any text that is coming from anywhere, guess what? Arasto, would you mind writing a line of code on your end and sending it our way so that we can pipe it into Remo Sharp?
Yeah, sure. So I'm going to send you a very simple line, a equals to x plus y plus c.
All
Here we
right,
go.
that sounds great. We got it here. And then what I can do is I can plug in, I can delete all the other file reading stuff that I had before, and I can plug it into the script input. And oh, I got a hello world. Let me reset. I think you need to send the message again. Would you fancy?
Yeah, of course. Just 1 second.
For some reason, it got
Yeah.
reset. This is also what happens
Here we
with
go.
net. There you go. Now we got it on our end, and you can see that this is doing the addition. And if I double click, the code is inside. Yay, hooray! This is awesome. Nice. So Arasto, this de facto means that Arasto from Japan can code in real time in on his end and have his changes affect whatever code I am running in my end here. A bit more elaborate so that we can
Yes, of
see like
course.
some actual geometry happening in real time from Japan.
Okay, so I'm going to send you a list of points that basically like
Whoa!
30 points. Here
30
you go.
points vertical on the screen. Oh my god.
Yes.
Beautiful.
Now, the cool thing about this is that you can change the x and y values from your side while I'm changing how many points are we going to get.
Oh, can we do that? I'm changing the values here
Yes.
right now. I'm
And
changing
I'm
the
going
X
to
and
change
Y.
this to 20.
All right. Are we coding
Or
together?
yes, we are.
From what are we? Are we like 20,000 kilometers apart or something right now?
You will at least 13 hours. So yeah.
We're 13 hours away from each other. That is very, very cool. Beautiful. Oh, excuse me. But this is not the end of the story. So these are the basic examples that I wanted to do for in the context of this playlist, Advanced Development in Grasshopper, showing you how we can do like hacky things with C# script components by piping in code that is coming from anywhere, a panel, a file, or some remote friend from Japan. Okay? But this is only the tip of the iceberg in terms of Remo Sharp. Remo Sharp is actually designed for much more intense and much deeper real-time collaboration between different people in different parts of the world. Arasto, would you like to tell us a bit more about what is your vision or the big picture, or what are the other things that Remo Sharp can do, and perhaps we can do an example of that?
Yeah, sure. Yeah, so Remo Sharp was kind of my idea to create something like a platform for real-time remote collaboration. And so basically the original idea was to like do scripting remotely. So remote C#, like hence Remo Sharp. And at the moment, it has grown to the system, to a system that would allow everyone to, not just programmers, but also non-programmers to do collaborative work. And basically what the whole thing is, you're going to have like one big file, one big canvas, and everyone is going to be working at the same time on it. And the difference with this kind of work and with conventional work is that, well, first of all, you're going to get one file. So that means no file management, no versioning, no nothing. And everyone is going to be working on the same file. So that's one plus. The other thing that we can do with it is, well, first of all, not everyone has the same level of skill. So one of the things that this kind of system would encourage is well, hopefully, people with higher skills and people with lower skills can work together and start to elevate their skills together. Also, this creates an opportunity for human interaction, which is something that we're kind of deprived of in these times.
We like human.
So,
We like human interaction. Yes, I do. I do.
yep, of course. And yeah, that kind of like the real-time aspect of that collaboration that kind of creates that kind of opportunity for that. So yeah, this is the final result of that.
All right, awesome. Do you think we can try an example of that more advanced real-time collaboration? Give us a second. We're going to set it up and we're going to show you what this is looking right now and what the outlook of how this may look in the future when you're watching this video could be. Give us a second. Alrighty. So let me get set up. We saved the file. I saved the sample file, right? And
So
I'd ask to remind me,
yeah.
please, to formally talk about your playlist by the end of the video and make sure that people know that there's a playlist, they can learn more, all the nitty-gritties, and that the playlist will be updated constantly with new examples and new whatever.
And by the way, about the viewport within Rhino, which I can like change stuff. Would you like to show that too?
Oh yeah. Let's show that. Let's show that. Actually, let's show that first. We had that as a file somewhere. Where did I have that? Well, I'm going to hide you for a second. I need to.
Sure.
Yeah. Oh, I don't know, but I had that. Okay, I guess I'll have to build it again because I've lost it.
Well, building that is kind of simple. You just need to have a website with client for one of the other servers, let's say 3, and you just have to connect a sync camera to the receiving message. So you create the sync camera.
So let me do that.
Toggle, yeah.
So client template, the URL, the website. Which server you want to use?
How about 3?
Server number 3. Okay. Server. And then I get a message. Hello world. Can you try changing the perspective one? All right. I'm receiving stuff, and I needed to control
perspective
client
one.
Client camera. Correct.
Perspective 1. Could you send me the exact name of that viewport?
Perspective with capital P, the first one.
Okay. So I believe I should be able to change that.
Yeah. Let me. All right. Try now.
Okay. Am I doing it?
Yeah, I'm getting a hello world
just
message.
Once. Oh, really?
Yeah.
How about
again.
now?
No. Did I need? I'm getting the perspective message, but it's not changing the camera. Did I need to connect? I have a trigger connected to the client camera.
You don't need a trigger.
Is it? Oh, it's sync camera. It's sync camera.
Sync camera.
All right, and target camera is the string. All right, can you try now? Yes, it is working. It is working. Yeah. All right, so I'm going to. Okay, I'm going to reset the file. Okay, I'm going to load some mesh or something.
And just one thing, let's have 2 viewports so that we can show that I can change one viewport while you're changing another.
All right.
So the whole idea, is more like 2 people watching the same thing with different angles.
Okay, sounds good. Let me bring in some models so that it's not just. Where do I have these models? Oh, you. Okay, you're gonna be rotating a model of my head. Hold on, let me save this somewhere, another in the file.
So if we're going to be doing that, then let's just let me see where exactly I'm going to be rotating from, because I really can't see what your screen looks like.
Yeah,
So
so
let's
just
give
just
it a
try to
second.
just try to rotate from the center of the origin of coordinates.
Okay. Let me see.
Right now I have you turned off.
Okay.
But I'm going to do ghosted. Okay. Ghosted. All right. Okay. So I think we're ready to start. So
Okay.
I'm all set up. Um, I'm all set up and I'm going to build something. I'm going to build this. Okay. Yes. So, all right, let's do this. So, for instance, one example of cool things you can do with Remo Sharp. So, we have this model of my head. Can you recognize me? Hmm? We have this 3D scan of my head right now, and I have connected to a WebSocket server, one of the Remo Sharp WebSocket servers with Bangest. So you can see that I can, for example, use viewport manipulation to change the rotation and the orientation of my cameras. But something that I can do is I can open up the synchronization of a viewport to be controlled remotely from by using Remo Sharp, for example. So what I can do is I can connect a synchronization camera component to the WebSocket server that I have connected to. I'm going to put in here a toggle, so whether if we want to update or not, and I'm going to connect here the message. I'm going to turn this on, and right now my Grasshopper is receiving potential messages from some remote server to change the orientation of the screen. And I can see that Arasto has already sent a perspective message. However, it's absolutely is way off the screen, Arasto. I don't know if you can, I don't think you can see it, but we can see that Arasto is right now remotely controlling my screen. But it went totally
Yes.
out, it went totally out of bounds. This is not looking great. But you can see the tiny dot
Um,
used to be me.
oh, really? So let me see where can I find it.
It is working, but it's totally so. The whole point of this example is that I can be controlling one viewport while Arasto is remotely controlling the other viewport, which is very cool. So that's one thing that you can do. Another thing that you can do, Arasto, and I think we're going to try this as well, is actually um, having synchronous Grasshopper definitions between different clients. Let us show you what that looks like. All right, and now this is a big one.
Yeah.
All right, are we trying this?
Yeah, sure. So, okay, so I'm gonna set up my broadcasting camera, broadcasting canvas here. So we're gonna have all the service things on your side then.
Please, please remind me what I needed to do. So,
Okay, so first of all, let's use server number 4. I mean, we have 10 servers, so let's use number 4. And I'm
okay.
gonna
Well,
start
I'm trying to load.
broadcasting.
I'm trying to load. I actually found the files.
Hmm, Okay,
Okay. Uh, So the system was connecting
You
here.
need, first of all, let's open a Canvas bounds WebSocket server from File Explorer. That's
Yeah.
going to register the bounds.
Okay.
And then
Let's open the let's run the Python file with the you see, you're making me use Python publicly in my live stream. You see what I have to deal with? Folks, the things I have to do for the community. Ew. I mean, look at me using Python. Ew.
it's a work in progress.
Oh my God. I was so proud of you until right now. Okay, I'm getting it. I'm connecting to server 5.
Yes. Let's work. So I am broadcasting everything. Okay, so this kind of seems promising. Okay, so let's go to
Oh, the
the
URL. I need the
Grasshopper.
URL.
Um, are you streaming your Canvas bounds outside of Grasshopper? Because then that's the only thing that remains.
Wait. So, okay, my canvas bounds. I needed to send them. What is the URL that I needed to use?
It's the from communication tools, IP, communication tools, or the one
Oh
on the
yeah, I
top,
got it. Yeah,
Canvas
that's
IP.
what I was missing. I was missing that.
Yeah.
Yeah, I am. Okay, so I'm sending that.
And we need a trigger for sending the bounce.
I have the trigger.
Okay.
What I am. So that's working, and I get the local server is sending stuff.
Okay, great.
And now what I'm going to do is I'm just going to restart the. I'm going to run the Python script again.
Okay.
So I'm going to copy this. Copy data only. Python.
And are we using server number 4 for the image?
Oh, I was using number 5, but I can use number 4.
Okay.
Let me use.
I can change it to 5.
Okay.
I just changed it to 5.
Okay, I got it. Wait, and the image is now stable. Oh, because of the offset. You're right. Okay. Ah, yeah. Okay, so
What we can do is let's offset the image to the left, and then let's have your grasshopper on the right, your grasshopper and rhino on the right. And then when you move grasshopper, it's going to move the image. So in your screen, we're going to like snap everything to the sides.
Okay, I see what you mean. Okay, so let me then. The scale.
You really can't.
The scale is different, I think.
You're going to have to zoom out.
No, but the scale of the bound. Oh, no, it's not different. No. Okay, I think I got this. So.
And then maybe we could just shift it a little bit down, a little bit to the right, so that it goes underneath grasshopper, maybe. I don't know. Or maybe just we could put grasshopper on top of it and then toggle the transparency.
I think we're just gonna show this side by side because it's gonna take forever for me to to calibrate this properly, and since I have the extra monitor problem, it's just going to be really difficult. So I think I'm going to leave that as an exercise for the viewer to just take a look at transparency and overlays and the setup.
Yeah. and you're
Wait,
actually seeing.
when I change the zoom level, the window moves.
Yeah, that's something in progress.
Okay.
There's a lot of things in progress.
All right. Can you do something? Can you change, move a slider or touch things? So I want to check because I'm zooming in. I kind of lost the connection, I think.
I feel it should be changing something,
No,
some
it's
stuff.
not
I
changing.
am just moving still.
No. Oh
Mm,
yeah, it's back now.
okay.
All right. Okay, so we're going to do that.
Okay.
Okay, so let's go back to all right. Okay, so let me introduce this. Let's go back. And here we go. What I have here on my right hand side is a Grasshopper definition with Remo Sharp that is connecting to a server and is receiving a live stream of an image of what is happening actually on Arasto's side. So what you can see right behind me right now is Arasto's Grasshopper definition in Japan that is being streamed real time to me. So I can see right now what he's working on. You can see those, you see those things moving? That's him changing them right now from Japan, all right? You can see those things moving. I can see what he's doing, what he's changing, and I could react to those changes. We could have a communication, we could work together. The setup of how this happened, it's a bit more complex than the basic setup. We have like a bunch of WebSocket servers and Python scripts, you making this happen. But long story short, right now I was able to establish a live communication with his definition and see in real time what he's doing. Um, Remo Sharp also has some features. So what I can do is I can actually make my grasshopper and his canvas both a little transparent, and I can overlay them on top of each other so that I could see the comparison between my file and his file. I'm not going to do this in this video because I have a lot of monitors and I was getting problems to properly calibrate the overlay and it was looking very weird. But if you're only working on one monitor, or if you have the time to put together that calibration, you could see that overlaid. And actually, he has a lot of videos. He very recently put together a full playlist that you can follow where you can learn how to install Remo Sharp, all the dependencies, how to run the background Python servers to make this happen, how to properly calibrate and overlay, and then remote synchronizing many things like the cameras, like the scripts, but also this overlay of components. All right, this is actually
Yes.
extremely cool. You want to say anything about the playlist? We're seeing the playlist right now on the screen, us
Yeah,
too.
sure. Just before going to the playlist, I just wanted to say, so this image that you're seeing right now that's being like broadcasted here, this is the whole idea. This is something like that connected to the idea of working on one canvas, and each client is going to be working on one part of it, and that part is going to be determined on where in the client you're looking at the canvas. So you can interact with stuff, you can create stuff, you can connect wires, you can delete stuff, all in remote. And it's kind of completely interactive. And about the playlist, well, I have basically created a full tutorial on how to use Remo Sharp, the current version, of course. So basically, you can use a remote scripting. You can do this kind of like overlaying Grasshopper together and like interacting with components remotely. You can also like create sliders or panels or toggles that you can like change stuff. So like imagine just having one box and three people are going to be changing X, Y, and Z in real time. So that's cool.
That is very cool. So a link to this playlist will be popping as a card on this video. There will be a link in the description of this video as well. You can probably expect that this list will change, will grow, will evolve over time as more features and more developments happen in the plugin, and I just noticed we're not subscribed. So if you fancy, please subscribe to Arastu's channel. And if you want to learn more when new videos show up, you can click on hit on the notifications, and then you get notified when new videos are published.
Cool.
All right.
Thank you.
Oh, thanks to you, and thanks to your contribution. Thanks for your contribution to the community. I hope many people will now have the possibility to do really cool stuff thanks to your work.
Thank you very much. Of course.
Thank you very much, Arastu, for being here. It was a pleasure to do this co-op video with you. Thanks to all of you who are watching this video and who may want to try to do cool things remotely with other people. And as usual, if you like what you saw in this video, maybe consider liking this video, subscribing to Parametric Camp, liking Arastu's videos, subscribing to his channel, etc., etc. All right, Arastu, what can we expect in terms of future developments? Where do you think the library is heading, the plugin is heading?
Well, right now, what I'm trying to make is, well, first of all, I'm trying to make it as intuitive as possible. So one of the things that we have to think about, so if we're doing remote work, I don't want to like increase the tedious things, like extra tedious things to do. So I'm gonna try making it as close as possible to working on a offline machine with your own Grasshopper file. And in addition to that, maybe something about performance or like internet latency and stuff like that.
All right, very cool. Thank you very much, Arastu. Thank you very much, everyone, and see you on the next videos. Bye bye. Say bye bye.
I,
All right, cool. How did that
yay!
feel?
Amazing.
Very
Yeah, the
cool.
best birthday present ever.
Oh, I got a message. Look at this. Python is not responding. That's what happens when you depend on, these kind of
Yeah, I know.
mediocre programming languages, All right, Erasto. Thank you very much for being here. It was a pleasure. Thank you again for your
It
contributions.
was amazing. Thank you
Eh,
very much for your time.
all right. And I'm going to continue. I still have about 30 minutes. So I think I'm going to continue recording a couple videos. One video is going to be, I need to record a clip that I need to add on to last week's video. So something I forgot to mention so I will insert that. That's why we haven't published any video yet this week. And I also want to make a short video where I discuss performance in terms of Grasshopper. So actually, would you like to join me for that video?
Yeah, sure, of course.
Okay.
I mean, if there's anything I can tell.
Yeah. So we're basically going to be talking about how performance as a developer gets better from vanilla Grasshopper to C# scripted components to actually compiled components. All right. So it's going to be a super short video, just making that very clear. All right. So,
Yeah, sure.
all right. So what I'm going to do is I'm going to close everything. I'm going to take a small bio break. I'm going to go drink some water. I invite you, Arasto, to take a bio break if you will as well. And then we're going to be back in 1 minute or 2 minutes. Okay. So
Yeah, sure.
we'll be right
Thank
back.
you.
We'll be right back, everyone. All right, beautiful. We are back. Okay. Arastu, I'm going to do, you're on the video right now. I'm going to record a tiny clip that was missing from last week's video. I'm going to do that real quick. I'm going to put you on the backstage for that one. So I would
Yeah,
appreciate if you mute yourself because the audio is still piped in. And then I will bring you back for that conversation about performance in Grasshopper scripts. Okay?
yeah, sure.
All right. Okay, so let me shut down. Oh, Remo Sharp. This is also going to be closed. I don't need this anymore. I'm going to shut this down. We don't need it anymore either. Source code. Oh, I didn't save examples. Yeah, okay. We can probably work on that soon. Remo Sharp servers. Okay. We do remote test. We don't need that anymore. I'm just going to shut down everything. I'm going okay, and then all right, so let me pull back. Oh. Let me pull in the videos from last week, which the videos from last week, custom display. Okay, and then I'm going to do a Rhino. Okay, is the audio? Yes, the audio is working. I'm going to bring in custom display. Oh, and I need a point. So I'm going to set 1 point, and then we get the vector length. Alrighty. And then the problem with this is that this gets clipped. Correct? All right, so let me redo this. Okay, I'm going to edit this from -100 to 100, and let's see if that clips it off.
Just one thing.
Yes.
I'm going to be testing the system, the whole Remo Sharp platform. So if anyone is interested in participating in the test, I would really appreciate it if they could just like send an email or like send a message on GitHub, on especially on Discord, on the Parametric Camp Discord. That would be really nice. I would genuinely appreciate it.
We can probably make a more formal announcement about that. I just put you on the video right now, by the way.
Yeah, sure.
We can probably do a more formal announcement about that. We can just publish that on the Discord server, or publish that on the Discord server, or I can also use. I'm happy to use the social media in Parametric Camp to like also bring in people for the exercise. Let's
Yeah, sure.
let's wait until you have a formal idea, a clear idea of what that's going to look like, and then we can make a formal announcement like, hey, just join. You want to join this experiment? Go to this form and put your email and whatever, and then Arasto will reach out to you.
Yeah, that would be super. Thanks.
More than happy to do that. Alrighty. Okay. I think I got this. Okay, I'm putting you back on backstage. And I'm going to actually, I don't need this for the video. Okay. Oh, and what am I actually? Okay. Oh, one thing I forgot to mention. So, what, doing this over again. Whoa, one thing I forgot to mention in the video. So, if you have tried what I just did, you may have noticed something that it's not working great. So, let's say I zoom out a little bit and then I really make the vector go out of, like make it like really large. We are getting into a problem. I don't know if you can notice here. You can see how the vector somehow kind of gets out of bounds or gets out of the renderable area that Rhino is computing for this vector. You can see that the arrow, because it's really far in the negative x direction, is actually not even being rendered. But that actually changed is if I zoom out, you can see that as I zoom out, all of a sudden the arrow shows up. But if I zoom in, this arrow starts disappearing. Why is that happening? Well, there's a long history of computer graphics technology that we will need to unpack here to really understand this. But long story short, what Rhino does in the background when it renders geometry is that in order to make sure that it adapts the rendering area for the camera, the frustum, and all the perspective parameters correctly, and it doesn't waste resources, what Rhino is doing in the background is that it's taking into account all the geometry that needs to be rendered, is creating this virtual bounding box around all that geometry, and then it's making sure that the rendering viewport, the cameras, and all the elements that need to display graphics on the screen are perfectly fitting everything that's inside of that bounding box. All right. This is a fairly low level thing from a computer graphics perspective, if you will. We typically don't need to care about these things because all the graphics that we display in modeling engines are taken care of by the modeling engine. But because we are engaging in computer programming and writing our own stuff, etc., now we need to start caring about these things. So we're getting this problem where Rhino is not aware that there is a custom preview that is made by someone in Grasshopper with this custom object and arrow, and therefore Rhino is not adjusting the viewport to the geometry of this virtual arrow. So how can we fix that? Well, it's actually quite easy. If you remember when we double clicked and we created our virtual overrides for the preview, we got the draw viewport wires override, but we also got a few other methods. This one, the draw viewport meshes, is very similar to this one, but it's for drawing geometry that is not line-based, like arrows or curves, or it's not linear geometry, if you will. It's geometry that has a surface nature. So I don't know if you're aware from other videos, but NURBS geometry, for example, is a mathematical entity that cannot actually be represented faithfully with computer graphics, because computer graphics can only render triangles in 3D screens. So you need to convert under the hood and in NURBS geometry into a mesh representation in order to render it to the screen. So anything that is surfaces and B-reps and that kind of stuff, you need to do your own conversion to a mesh before you can do custom preview of those objects in the viewport. I should have actually made an example of that, but I haven't. You're welcome to try that on your own or to check our sample files in the GitHub repo. But the other function that I wanted to point you to is the clipping box function. The clipping box function is a function that Grasshopper uses to retrieve a bounding box representing and containing all the geometry that should be rendered. You can see that by default, it's an empty bounding box. But what we need to do here is we need to calculate a bounding box that contains the full arrow of geometry so that when that bounding box is passed to the Rhino renderer, the Rhino renderer adjusts the view to all the geometry that we are custom previewing. This is just as easy as saying, well, the arrow object which is living in the global scope, literally the first property that pops up in the autocomplete is bounding box, because all geometry objects, all objects that inherit from the geometry class in Rhino Common, they have a bounding box property, all right? So surfaces, B-reps, points, whatever, you can get bounding boxes. There's methods to calculate bounding boxes in Rhino for all elements. So as soon as I finish this, you can see that the arrow all of a sudden goes all the way to where it's supposed to be. And now, no matter how big or small I draw my arrow, Rhino is not going to clip that arrow and keep it outside, because it knows that there's a bounding box object that contains all that geometry. All right. So long story short, remember whenever you do custom previews that you also need to tell Rhino what is the bounding area that contains all the geometry, so that Rhino can adjust rendering to properly not clip any of that geometry. All right. This is part of the optimization processes in computer graphics. All right. Sorry. That was something I forgot. I actually recorded. You can see my shorter video. I recorded this after the fact because I forgot to make this in this video. All right, let's go back to the main video. All righty. Okay, that was it. I don't need, do I need to save this? I'm going to save this. I'm going to save this in, where are we going to save this? Yep. All right. Okay. And for that one, okay, Arasto, I'm bringing you back in. Okay, so I wonder if there's an example, a quick example that we could do right now to show performance. So what I want to talk in this video, I want a really short video where the bottom line is Grasshopper is good, but C# scripting is better in terms of performance, but compile components are even better in terms of performance.
Would you like to give
you're muted.
multi-threading a try?
Oh, no, sorry, no, you're not muted. I don't have this, so I can't hear you. All right. Now I can hear you.
Would you like to give multi-threading, a very simple multi-threading sample a try?
No, I don't think so.
Too advanced.
Too much. Can we do multi-threading out of the box in Grasshopper?
Yeah, I guess we can do multi-threaded for loops, which is quite easy. Not exactly quite easy, but it's manageable, I guess.
All right, so
or we could just say that we can do this with programming, and with vanilla Grasshopper, you can't do that.
So what could be an example? What could be a very heavy operation? Like a for loop, like a for loop with 1 million objects, something like that, that we could do in vanilla Grasshopper. And then we could replicate in C# scripting, and then we could also do with a Grasshopper component.
Maybe creating a 3-dimensional array of points. That can get quite heavy.
That's not a bad one, actually. That's not a bad one. Which one component would we use from the vanilla toolbox to do that?
Do we really need to use one? Because if we're going to be talking about vanilla Grasshopper, that means that we have the constraints to use multiple components.
But that's the point. That's one of the points of why performative vanilla Grasshopper is not that great. That's why packing a complex set of operations in one compiled component is much more optimal. Okay. I'm looking at Grasshopper right now. Do we have like a 3D grid of points of sorts?
Maybe we could create a 2D grid and then move it with series up.
Yeah,
That
but
could work.
at that point, you're already...
Let me see. Array, box array. We have a box array.
Box array? What
We
is
can
that?
give it a point.
Box
It's
array.
in transform. It's in transform an array.
But this one is using, yeah, geometry, box array cell, number of elements. Oh, I see what you mean. Yeah, but this is not clean enough. It's not clean enough because the way to do this would be that this component would be using transformations which are heavier than a simple XYZ creation. I don't think this would work. Well, we could just do a 2D grid. If it's dense enough, it will probably be enough, you know? So let's say we have a point. That point. Let's say we bring it that point, and then we want to say X direction. Okay. Let's say we do this, and then we do 500, and then we do this, and another 500. So this is X, this is X, this is Y, and this is series. The number of values here, here. Step size, the step size, and then we generated this, and then we move the object. We have 500 points, and then we move the objects, and we get this much, and then we have to flatten this. Okay, and it's already... No, we have to craft it. And it took half a second to compute. Enabled. It took half a second. All right, so that's one thing. That's one way to do this. The other way to do this would be a native component. This point, size in the X direction, size in the Y direction, components in the X direction, components in the Y direction. It takes 1.51, which is kind of nice. So that's actually doing what we expected. So that's one thing. So that's one group. Oops. And then the C#. Now I have to write code. I thought I was off the hook today. Okay, all right, so...
Maybe you could have used Remo Sharp while you were doing all those stuff.
Whoa, look at what he just said. Absolutely, you're absolutely right, sir. We could have done this a bit smarter by using Remo Sharp. So this is a double, this is an integer, this is a double, and this is an integer. How do you pronounce that? Integer, right?
This is integer.
Okay, so and then I create a list of point 3D objects, a new list, point 3D. Oh. Point. And then with the for loop for I equals 0, I is less than number of elements, I plus plus, and then for j equals 0, j is less than number of elements in the y direction, j plus plus. I don't know how many times I've written this for loop in my life, like a nested for loop. And then what we do is 2 points. We're going to add a new point 3D with coordinates p dot x plus x times I. Then p dot y plus y. And then this that didn't work because I am missing a parenthesis because I'm a very sloppy coder. Oh no. Oh no. Ew. We have a problem. Okay, so maybe I start.
Sometimes
I do an
once you
array.
compile it.
Well, the C# component actually has a worse performance.
How about not having it out? Like, how about not having an output? Because I've seen that with points, it's actually quite interesting that if you don't output it, then it's gonna like do it like with a snap. But if you output the geometry, it's gonna make it much harder.
But then it's not a fair comparison because all the other
Yeah,
components are outputting stuff. You know, it feels like cheating.
yeah, of course.
That we can probably do. Okay, let's try with an array instead of a list. What? Still? Oh boy.
Maybe it's the compilation. Once we change.
Oh, you're absolutely right. No, you're not right. Takes a full second to do it with a C# component. Whereas native is 125 milliseconds and Grasshopper is half a second. That's not exactly the point. I wonder if I'm doing something stupid. Well, you have a lot of robots today. Interesting. I did not expect that. Am I outputting more points than? No, it's the same amount. Ew. I see. Victor is pointing out that C# is actually not that fast. Well, I guess we can just talk about that in the live stream as well. Why not? I mean, it is what it is. It's not our fault, really.
Yeah, but still, I prefer to do C# coding instead of Grasshopper.
I know, and maybe for this simple example where we only have 5 components here, it's still performing better, but when it gets more complex, it's definitely C# definitely cuts it's much better. Okay. Maybe if we actually did this in 3D, that's where we would get an advantage.
Yeah.
Victor is pointing out, for those times that I have noticed a difference is when I'm writing a C# for a long process without outputting the in-between info. Yeah. That's similar to what you were saying. I agree with that, yeah. Okay.
Actually, I've had an experience just like that. So something that would take about like 45 minutes with vanilla Grasshopper stuff would take about 7 minutes with a C# component. And when you do multi-threading on it, it's going to go down all the way to 3 minutes.
Okay. All right, cool. All right, so this video should be very simple and very quick. It's mostly about just a reflection on performance comparisons. All right. Okay, Arasta, we're doing this.
Yeah, sure.
Hello, this is Jose Luis here at Parametric Camp, together with Arasto, who's also a member of the Parametric Camp community, and whom you may know from our previous video in this series, the one where we were talking about Remo Sharp. In this video, I just wanted to make a very small example and some reflection on issues of performance. Because if you're following this series, Advanced Development in Grasshopper, it's probably because you want to supersede what you can do out of the box with vanilla Grasshopper components, but also because you are reaching a level of complexity in your definitions and your Grasshopper work that is kind of outpacing what Grasshopper can keep up with. And it turns out that when you actually write your own scripts with computer programming languages or compile your own plugins, you actually gain a lot of performance. So for example, let me show you 2 examples or 3 examples here. We have an example where we have a point and we want to create a very dense grid in 2 dimensions with those points. The way I have done this is, first of all, I've done it in vanilla Grasshopper. I've created a couple series, I've replicated the points, and I have copied them as an array. If I turn this on, you can see that I have created 250,000 points, which is already on the heavy side of things. And it took Grasshopper 600 milliseconds to compute this operation. All right. So ideally, what we want is to be able to achieve this performance with, achieve this operation with a higher performance, like taking longer, because this, we might be able to afford 600 milliseconds, but if we actually have many operations that are this heavy, or if we start now working with this 250,000 points in further operations down the road, it's going to be heavy and tedious very, very fast. So you can see that, for example, if I try to mimic the same operation, I'm going to turn the visualization off. If I try to mimic the same operation with a compile component, one that does everything in one go and is actually being compiled, like the way we will do plugins in further videos down this series, if I enable this video, you can see that the same amount of points, actually a few more points, so more than 250,000, are actually being generated in a sixth of the time, in 100 milliseconds, which is great in terms of performance. It's actually a huge gain. But what about C# scripting? Well, it turns out that if I replicate the same example in a vanilla C# script component, so for example, with a double nested for loop, taking the coordinates of the first point and using that to generate new points. If I turn this on, what we can see is that it actually takes longer than this one component to execute. Actually, C# script for this one particular example has worse performance, surprisingly, than doing it the vanilla Grasshopper way. When we were putting together this example, we expected the performance of this one to be better than vanilla Grasshopper, but a little worse than compiled components, because in general, the way performance in Grasshopper works is that using Grasshopper vanilla components is the least performative way. It takes more time just because Grasshopper has a lot of overhead of all the individual operations that need to happen in all the different components, but also all the overhead of communication, data transfer between the components, etc., etc. So if you are an intermediate advanced Grasshopper user, you may have noticed that large Grasshopper definitions are very heavy and very laggy. Okay. We expected the C# component to be better because what C# components do is that you can bundle and pack all the operations that you could do with individual vanilla Grasshopper components into one single script that then gets compiled in the background by Grasshopper and then gets executed. What we found here is that in this case, for this simple operation, all the overhead of compiling the C# component in the background, etc., etc., led to more expensive compute times. Whereas the actual natively compiled component, a component that already bundles all that code that doesn't need to be compiled because it's already pre-compiled by Grasshopper, outweighs everyone else in performance. So what Arasto and I wanted to share with you is that in general, vanilla Grasshopper components, arrays, and definitions that have many of these are the least performative way to go. C# scripting gives you an advantage on that, and compiling complex operations into native plugin components is usually the best way to achieve performance. What we suspect is that in this particular case, because the operation was actually not that complicated, the compilation time was worse and gave us all this overhead, and that's why it didn't compare so positively with vanilla. However, it has been both of our experience, etc., etc. And if we were to replicate the same amount of operations with a C# script component, very soon the compiled C# script component will overweight and will have much better performance than a complex Grasshopper definition. Is that correct, Arasto? What do you think about this?
Yeah, that is completely correct. And well, to me, like in my experience, the reason that I prefer to use like C# components instead of like writing everything in vanilla Grasshopper is, well, first of all, of course, it has something to do with performance, but of course, writing things in C# is going to give you much more. You can do a lot more with writing C#. And like, for example, you can do, even in terms of like performance, you can do multi-threading, you can do like a lot of stuff that are gonna drastically reduce the time that you're gonna be spending on calculation. So that it's the difference between like 30 minutes and 7 minutes up to like all the way down to like 3 minutes for the same operation. Now, that's one thing. Also, you get to use everything that comes with Rhino and Grasshopper, along with everything that comes with C# itself. So that is a very cool thing to have inside the environment of Grasshopper.
But the best of both worlds.
Exactly.
Beautiful. Well, maybe at some point we record an example where we actually show that level of improvement in performance. Also, as Arastu is mentioning, multi-threading is also something that is possible when you are in C# world and when you are in compilation world, but it's not so possible in vanilla Grasshopper, I believe. I'm actually not entirely sure about that, but multi-threading is always something that gives you an advantage because you're using all the CPUs concurrently at the same time. All right, something that Arasto likes a lot because he likes like real-time things working together, etc., as we have seen in previous videos. All right, So yes, so writing your own code typically leads to much better performance, especially if you are able to supersede C# scripting, which is great, but it has some drawbacks, and you can start creating the same thing that you are writing in C#, but compiling it natively into plugins that you can load into Grasshopper, that you can distribute to the world, etc., which is going to be the main topic that we're going to engage in the next videos down the road in this playlist, in this course, Advanced Development in Grasshopper, which I'm actually really looking forward to. All right. So thank you very much, Arasto, for joining in this coffee talk about performance issues in Grasshopper, you know?
Of course, and thank you very much for having me.
And thanks to you, the viewer, who are watching this video for dealing with our sloppy coding and our poor examples to try to make a case about things that we can't really show, you know. But anyway, we can talk from experience if you trust us a little bit. Anyway, thank you very much. If you liked what you saw, maybe consider subscribing to the channel or liking this video. And I will see you in further videos in this series where we're actually going to start creating our own plugins from scratch. No C# scripting anymore. I mean, we're going to be using C# as the programming language, but not the scripting component. We're going to create our own native plugins like Arasto does in his free time. Thank you very much and see you on the next video. Bye-bye.
Bye.
Beautiful.
So,
All right. So I think that was it for today.
yeah. Again, thank you very much for having me on the stream. It was amazing. An experience of its own. Perfect.
Anytime. It was a lot of fun. You know me already. I like doing this with people. You know, that's why also I like doing live streams, because I feel connection with human beings. You know, human interaction, as you were saying.
Oh,
Anyway, thank you very much, Arasto. I'm going to move you to the backstage. See
Hey,
you
yeah.
somewhere physically or online, whatever.
Hopefully soon.
Bye bye. All right. And for everyone else, thank you very much for being here. I'm going to take off. I have a full Friday ahead of me. And yeah, and this was actually a lot of fun. I think we need to do more of this like cross live streams or whatever you want to call it.